Hello everyone, welcome to the final lecture of week 7. So we have been discussing applications, and today we'll talk about text summarization and another application. So we will talk about what is text summarization, different type of methods that we use for summarization. We will take one domain specific example for this, and we will briefly touch upon how do we summarize long documents before going to evaluation of text summarization. So how do we typically define text summarization? So we call it, so typically what we have a given document. It can be a set of documents also together, multiple documents, and we want to condense the information present in these documents in a very concise and quickly readable manner. So I want the most relevant information, and that is what is the summary, in a very concise and quickly readable manner. Now summarization has been researched a lot. I mean, lot of approaches, lot of benchmarks exist for this problem. There are methods from rule based methods even to large language models have been used for this task. Now when we talk about summarization, there can be various kinds of summarization. Like we can define based on what kind of output do I need. So my input is, let's say, a document, right? So now I may just want to extract the most relevant sentences from there, and that has been one of the main body of work for many years, that you find out the important sentences from this document that are relevant to be put in a summary, and this is what is called as extractive summary. So here you typically search what are the important sentences in the document that are relevant, and you just present them in a nice manner. Or you can summarize like the way humans do, where you understand the important information and rephrase it as needed in your own terms, so that it becomes more readable, and that is what is called the abstractive summary. Okay. Now the length may be same. In this example you are seeing length for abstractive is smaller than extractive, but the length is not an issue. You can have extractive and abstractive of the same length, right? But you will have a concise, more concise information in a summary than you had in the original document. Now another categorization is based on the number of documents in the input. Let's say you have multiple documents in the input and you want to produce a summary. Summary will still be a single like summary, right? It won't be multiple documents for so here your source is multiple source documents, and that's why it's called a multi-document summarization, right? In contrast with single document summarization, where you had put a single document as the input. Now I can talk about general summarization, so or it can be based on certain content or genre, right? So maybe it is about news summarization, that's typically more generic, or it can be about legal summarization. So you are taking a legal judgment and trying to summarize that, or it can be about a financial report. Your financial report, you are summarizing that, or you may summarize a particular book, right? So you can do summarization for in general for news articles, or you can do summarization for domain specific problems also, and this problem has been researched for like wide variety of domains. Okay. So the interesting thing is that we will see there are evaluation metrics in general, but also when you go to a domain, you may cater to the specific need for the domain, right? So we will see, for example, when we go to financial domain, it's very important that whatever summary you are producing, the numbers are very correct, right? You're not making up numbers there. So you may have a metric to measure how much the numbers that you have generated are correct. Okay. So coming to a brief summary of what kind of approaches have been used. So before deep learning, so approaches were mainly like lex-rank centroid based, where what you would do, you will take the various sentences, create a graph based on their similarity, and then choose the one that is very similar, right? You can use PageRank kind of methods here. Another very popular approaches that have been seen even recently are integer linear programming. They also not so they are also do not use any machine learning methods. So what these approaches do? So you specify your requirements as certain constraints, right? So and these constraints are satisfied. So maybe constraint can be I want to maximize the number of verbs in my summary or proper nouns in my summary, right? So you would select those particular sentences that would maximize this objective, right? So you can define your objectives very carefully depending on your task, and you can do integer linear programming. So that has been a very popular approach for summarization also. And then while you are doing that, I mean, one thing you will have to keep in mind, you don't want to keep on selecting the same summary presented in different same sort of information presented in multiple sentences. So you say, okay, what is the maximum marginal relevance? So what is the, once you selected one sentence, what is the further relevance of the next sentence, right? So accordingly you will select that. So this is again a very important concept that is used for summarization, but they were like before deep learning. Now with deep learning, people started using starting from LSTMs to transformers, pre-trained transformers to large language models for doing summarization. Like this is a paper BERT, very like came in 2019, very close to when BERT came in. So what they said, okay, so you have a document which will have sentences. So this was an extractive summarization task. So what you will do, you will put sentence 1, sentence 2, sentence right. I mean, so you can keep on putting sentence one after another and have a CLS token. For each sentence, you will have a separate CLS token, okay. And this CLS token will tell you whether, I mean, you want to classify here whether I want to include this sentence in the summary or not, right. So binary classification per sentence. So then, I mean, very similar to BERT, you can put the token embeddings, segment embeddings, positional embeddings, and when you get the final embedding, you can have a binary classification whether I include the sentence or not, right. So you can train the model accordingly. So this was BERT paper, very simple way you can use BERT for, you can fine tune BERT for doing the summarization task. Now in general, so this was a like some sort of sentence classification task. Each sentence you do a binary classification and find out which one I would use. Now you can also treat it as a generation task, like you have, so what you can do, so suppose you already have a label data set. So what I will do, I will take I will fine tune some model. So it can be, because summary you can treat as generation task, I can use an encoder decoder model or a decoder model. So I can choose T5, FLAN-T5 as some encoder decoder models, and for decoder I can use GPT, Llama and so on. So that's typically the preference if you have a label data set. But if you do not have a label data set, then if you can label, you would do labeling and then go via this route. But if you cannot label, you can do prompting, and you can prompt the open weight models or models that are very large, but you can still do few shot prompting. So all these decoder only models, typically Llama and Mistral and all, you can prompt with this, okay. And whenever you are using encoder decoder models, or whenever using decoder only models, what you would do, so you are generating summary, so one word after another, you can simply use the language modeling output layer and just keep on generating the next tokens as your summary, right. So that's a simple auto-regressive generation that you will do while using decoder only models. Okay. Now focusing on abstractive summarization, so your input is a document and output is a summary, right. And you can fine tune a model like GPT-2, T5, BART, right, or even Llama, Quen, Mistral models, or you can prompt a model without fine tuning. So you can have various kind of approaches possible. So like I can use these models like BART, T5 are like general models that we have talked about. Then Pegasus, CTRL sum and Brio are specific models for summarization. Okay. So you can start from these models and then further fine tune them for on your task, right. That is a very standard approach. So you can have task specific models for each data set, you can train them, fine tune them. Or you can you already have instruction tuned data sets with multiple tasks, and you can do prompting. In the prompting you can specify the instruction, right. You can even instruction fine tune them. Now, what is exactly instruction fine tuning? We will learn just in the next week, right? So, you can instruction fine tune these models or use the instruction fine tune models to do prompting. You can also do zero shot prompting. So, with models like GPT-3, Palm and all, right. So, these are the kind of approaches people typically use, and they are very standard. Like, how do you use BART? You will feed the document. So, you have the encoder and decoder is already pre-trained. So, I will feed the document in the encoder, and the decoder will start generating the summary, right. So, I can fine tune if I need. I can fine tune my BART models weights for summarization task and then use it for summarization. Same thing I will do for T5, right, or Pegasus for that matter. So, just to give an example what is the Pegasus architecture. So, it just use a different pre-training objective for training, so that it can be better at summarization. So, what it does, so this looks like very similar to the kind of architectures we saw for pre-training. So, let us say this is my input text. Pegasus is mythical, it is pure white, it names the model, right. So, what you will put in the encoder, so you are removing mythical and putting a mask 2, you are removing this entire sentence and putting a mask 1, and removing this word and putting a mask 2, right. So, this putting mask 2 looks like mask language modeling, but what is mask 1? So, this is what they said as gap sentence generation. So, you have some gap sentences. So, you take an input and some of the sentences you call as gap sentences, right, and you mask those in the input, okay, and it will go through the encoder like it used to go in the normal T5 or BERT kind of setting. You will predict the mask tokens, okay, in the encoder itself, and the decoder you will generate the mask 1 tokens. I mean the sentence that you have put as gap sentence you will generate. So, you are generating it, okay. So, what they found that you can do this mask language modeling and gap sentence generation simultaneously, okay, as the pre-training objectives. So, and this is what helped them in training this model better, so that it can do summarization, because one of the tasks is generating the sentence that is missing, right, gap sentence generation. Now, to make it make the pre-training better, it will be ideal if the sentence is selected as the gap sentence is a relevant summary sentence, right, that is sentence you want to put in the summary, it would be much more helpful. So, how do I find out sentences that I need to select as gap sentences? So, they used certain heuristics, right. So, they had 3 strategy. So, they selected M gap sentences without replacement from a document containing M sentences. So, one is that you uniformly select M sentences at random, right. So, this is like the very basic idea. You can randomly select some M sentences, or you can select the lead sentences, because many times people have seen when you are trying to summarize a document, the initial few sentences are very, very important. So, they just approximate these as the summary and put them as the gap sentence, or they use a more principal method where they will select the top M score sentence according to the importance. So, what they did, so they compute a Rouge 1 score between the sentence and the rest of the document. So, you take every sentence and the rest of the document, compute a Rouge score. Now, what is Rouge score? We will study in this lecture itself. So, this is a way to evaluate how good a summary is, I mean with respect to a reference document. So, it is more about whether this sentence is important sentence, it will have some similarity with the rest of the document, right. So, they use that particular proxy to select top M sentences. So, they used these 3 particular methods, and this principle actually worked better in their favor, and this Pegasus model is available, and people have been using this as one of the main models than say BART or T5, because this is already pre-trained for summarization. So, it is better to start from here and fine tune your model for summarization. Okay. Now, coming to an example of domain specific text summarization. So, we have taken a particular case where we are trying to summarize in the financial domain, and what is our document? It's an earning calls transcript, right. So, what happens, I mean, so every most of the companies have every quarter they would have an earning call. They will discuss about the company's earnings, revenue, and what is their plans for the next quarter, right. So, and this conversation is actually quite long and recorded in an unstructured document, average length roughly 3000 words. Now, a very important thing is find out what are the important insights from there, right, like for financial people. So, you may not want to read this whole 3000 words, but what are the important insights. Right. So Motley Fool website, for example, they have these transcripts already hosted, and we have in this work, so Russell 3000 companies were collected, their ECDs were collected. Now, see, once you have the document, the next thing you have to do is find the summary, right. So, how do you find the summary? So, one option can be you can manually you can hire some domain experts who can create the summaries, right, and then you can use that to train your model. But it is difficult to do that at scale for a domain like financial domain, because you need financial experts to be able to create these summaries, right. So, it is very crucial if we find out some automated way we can collect summaries, right, for certain domains. Like here, like for example, when we talk about a scientific domain, many times the abstract of a scientific paper is considered as a summary, right. So, then you can collect a lot of data where you have the whole document and the abstract, and you can train models from that. Similarly, is there some automated way in which we can collect the summaries? So, that is where so what was found, you can use Reuters. So, Reuters had some expert written articles, okay. So, corresponding to these earning call transcript, they had some nice summaries as bullet points, okay. So, it is a telegram style bullet points, like quarterly earning per share is $1.52 and so on. So, they have some specific bullet points in a telegram style, okay, and they were capturing the metrics and numbers that are discussed in the calls. And average length was very short, 50 words. So, we are starting from 3000 words input and going to 50 words, right. So, it is a huge huge condensing of information that you are doing with the summarization. Now, so now that you have the data, you have the input document and the summarization, that you have collected. So we can see how challenging is the task. So, you can try to compare certain quantities. So, for example, first of all, what is the size of the data set? So, ECD sum, this particular data set was 2425 documents, and with their corresponding summaries from the Reuters. So, one thing I would like to point here is the compression ratio. So, the compression ratio between the original input and the final summary on an average, taking an average of the compression ratio, was roughly 103, right, and it is higher than other sort of this large document summarization data sets like Big Patent, which has 36, Archive that has 31 and so on, right. So that means a challenging problem. You have to do a compression roughly of the order of 100, right, from the input to the source document. Now, how do you approach this problem, right? See, one problem immediately that happens. So, if your input is 3000 words, right, and once you convert into sub words, it will be even higher. Many of the models like T5, they would not be able to fit that entire document into their input, right. So, that will become a problem immediately. So there needs to be a way in which we can actually solve the problem for a long document. So one option is that, okay, so you can do it in two phases. First you do some extraction and then you do some abstraction. That is a very popular approach. You first extract, where you take each sentence as input and try to classify whether I should include that in my summary or not, right, like the one that we saw earlier. You can do it for each sentence independently, and you can have a sentence label GRE, so that you can have a idea, okay, whether I included the previous sentence or not and including next sentence or not, right. So, you can give a long document and you can extract what are the sentences that I should finally take in my summary, right. So, that is one example. So, you can feed sentence by sentence, so that it can easily fit into a BERT model, and because the financial domain, FinBERT was the model that was used. This is the extractive model purely. Each sentence you have a binary yes and no. Now, what does this first phase give you? Are some sentences that you want in your summary. Now, the second phase can be, you can simply take them to another model like T5, BART, Pegasus, and create an abstractive summary, right. That is one option. But in this work, because even the style was very important. That finally we wanted to get telegram style bullet points, right? So what was done? So you feed the sentences one by one and try to paraphrase these to telegram style. So you train this model, paraphrasing module, that will take a sentence and convert into corresponding telegram style target, right? So that was a very interesting aspect of this solution. So that means you won't reduce the number of sentences here. So you will take all the sentences, each sentence will paraphrase into the telegram style bullet point. Okay. But yeah, you can do some abstraction also at this point of time. So here you use a T5 encoder decoder for doing paraphrase. Now the paper discusses various approaches that were used. I mean, so you could try all the unsupervised approaches for this. You can try extractive approaches. Now, and these are some abstractive approaches. You can see BART, T5 Pegasus. Now, because the documents are long, so one can say, okay, I will directly use a long document model like Big Bird, and long T5 is a long version of T5. LED is just long former with encoder decoder. So you can have a long former with encoder decoder architecture. So and you can see that across these models. So in terms of Rouge 1 and Rouge L, you find that these models like LED perform very well compared to other models, right? And this was their approach, where they use this ECT BPS approach. I mean, that was the name for the module, and it gave even better results than the LED, because it was very task specific, because you knew that you have to extract some sentences and then do paraphrasing. So that's what it was doing, and it was getting much better results. So these are the standard metrics. So we talked about BERT score also earlier, that can be used for measuring performance of summarization. But what is different here for the domain are these two quantities, the numerical precision and summa conv. So what was this quantity, for example? So because you are generating tokens and the sentences, like one of the problem is the hallucination. You can generate something that is not in the source sentence. So that's why you have a measure on whatever numericals you have generated, are they correct or not, are they present in the source document or not. And you can see certain approaches like BART had a very low numerical precision, that means many numericals were not even present. And while this proposed approach, it takes it to roughly 0.916. Right? So one trick that they follow, for example, is that they mask all the numericals, right? And then they when they come back, they will go put the mask back. I mean, they will remove the mask. So that was some nice trick. And similarly, there was another metric for measuring how faithful is the summary to the original document. Now, one thing though I will like to mention here, like to train this model from original document to extractive summary, you need some ground truth data on what are the sentences that should be in the extraction, right? But this data set is not always available. You may have the final summary, but you may not know what sentences, right? The middle, this is the middle step. You may not know what are the sentences that are relevant, right? That should come in the extraction summary, so that you can directly do an abstraction over that. So what people have done, for example, so they would take their ground truth data and find out the sentences in the source document that are very similar to that, right? And that they assume as a silver standard, that okay, so this we will assume as the silver truth for the extraction, and use that to train this extractive model. So this is a very popular approach. Okay, so once you have that, you train your model, extractive model, and then you can go for abstraction. But in general, how do you handle very, very long documents, even like books? So what you can do, you have a very long document. So naive method is you just chunk it, right? So you have a book, you create multiple chunks for that. Now you can summarize each chunk and then append the summaries. Like there, you have to be careful that okay, how many chunks I have and what is the final summary length that I require. So you accordingly create summary for each chunk so that you can combine, right? The problem there is information loss. I mean, you are summarizing one chunk and the second chunk is not using information from the previous chunk, right? That information is getting lost. So you may lose the context here, right? And you may not know from which chunk I should take a larger, more number of sentences than another chunk, right? So you will typically produce equal length of summary from each chunk and combine. That may not be the optimal way of doing things. So, what is the other kind of approach? So, this particular paper um, proposes two interesting strategies. Right? I mean, so what they said, okay, fine, you have divided the whole book into chunks. Now, you take the first chunk and create a summary. That's common both. Now, so the question is, how do you incorporate the next chunk, right? Because your limitation may be in your prompt, how many words you can give in your prompt when you are using LLMs, right? So, what you can do, let us say I can create a summary for chunk 1, create a summary for chunk 2 independently. But now I use these two summaries together and create a new summary, right. So, that way you are not losing the context now, you have the context from the summaries, right, and create a new summary. Same way you do for summary 3, summary 4, you merge them with the context, you create a new summary. Now, again you merge them to create a new summary, and while you are merging, you can take into account how many words do I need in the final summary, right. So, suppose I need 100 words, each of them may be 100 words, but okay, when you are merging that, you can give this constraint in the prompt that I want the final summary of 100 words every time, right? That is possible. So, this is hierarchical merging approach. Second is an incremental updating, that is, okay, I had the chunk 1, I created a summary, say 100 words. Now, I got another chunk. So, you give that chunk and the previous summary in your prompt, right, as an input, and you create a new summary that takes into account whatever you have seen till now, right. Very similar to how you do in the RNNs, right. And then you have a new chunk, you take the previous summary and the chunk and create the new summary, and you keep on doing that, right. And if the summary becomes too long, you try to compress it. So, whenever it is beyond the length that you want, you compress it further. So, this is the incremental updating. So, these were the two methods that were discussed in this particular paper for doing summarization with very long document that you may not feed into your prompt, right. And the good thing is that they try to take care of the context with them. Now, finally, I will talk about the evaluation, that how do you evaluate summarization. So, the standard metrics are like you can use BLUE. So, BLUE metric was originally proposed for translation. So, you have in machine translation, you have a source sentence, target sentence, and you have an output. You have an output and a reference translation. You want to compare how good is the output to the reference translation. But the same idea works for summarization, that you have a reference summary, you have a generated summary. So, how close is the generated summary to the reference summary? So, how BLUE works? So, it computes precision, that means whatever you have generated, how precise that is, for n grams of size 1 to 4. Okay. And if you are really generating very short, because if you generate very short, you may get good precision. So, they even penalize that by using some brevity penalty. So, this is minimum of 1 and output length divided by reference length. So, if you have a short summary compared to reference length, you get a brevity penalty, and then it's simply a geometric mean of precision from n gram 1 to n gram 4. Right. So, just to take an example, let us say this is my reference summary, right. Israeli officials are responsible for airport security, and you have two summaries given by two different systems, and these are the matches that are proposed. So, how would you compute the BLUE score? So, I will have system A, system B. I will first compute the precision for 1 gram to 4 gram. Say for 1 gram, the precision is here 1, 2, 3 out of 6, and for system B, all 6 are matching. So, 6 out of 6. 2 gram precision, you are matching 1 out of 5, okay, and here 1, 2, 3, 4 out of 5. 3 gram, there is no 3 gram matching in system A, and in system B, 1 and 2, 3 grams are matching, and 4 gram, none here in system A, and system B, there is 1 4 gram out of 3. Okay. So, you got the individual precision, and you know immediately that your system A will get a 0, because like some 3 gram 4 gram precision is 0 for this. For system B, because everything is non-zero, you also have to compute the brevity penalty. Now, brevity penalty will be like how this system B output is 6 words down to 7. So, you will have 6 by 7 as the penalty. So, you will now say 6 by 7 and a geometric mean of this. This gives you roughly 52% as the BLUE. Right. So, that is how you compute the BLUE score. Now, what the issue with BLUE is that it is more focused on the precision, right. But so that is why in summarization, a better evaluation is ROOJ, that is more focused on the recall, because see, you have a reference summary, you want to ensure that you have captured the main points from the reference summary, right, and that is why recall makes more sense. So, what is the rule? How do you define ROOJ N? typically we say for recall. So default when you say rough, this will be recall, unless you mention you're doing it for precision and so on. So that is how many n-grams are there in the reference summary and how many of them you have already captured. Right? So for example, Rouge 2 has been very popular. So suppose this is your reference summary. The quick brown fox jumps over the lazy dog, and the generated sentence is a quick brown fox leaped over a lazy dog. Right. So what you will do, you will find the bigrams in the reference summary. Okay. So these are your bigrams in the reference summary. You bigrams in your generated summary, and you say how many are overlapping. So you say 1, 2, 3 are overlapping out of 8 in your reference summary. So your Rouge 2 score will be 3 by 8. Right. So that's how you will compute your Rouge 2. So you also compute typically Rouge 1, that's based on 1 gram. So people typically do Rouge 1, Rouge 2. They also do Rouge L. That will just simply say what is the maximum length subsequence over the in the output that is matching in the reference, and it need not be contiguous. Right. So that is another measure. And you can use by default BART score, but there is also another score that is popular, that is called BART score. So what is the idea? So let's say you have this your reference. This is your reference summary. This is your source document, and hypothesis is what you have generated, right? So BART score is simply defined as what is the probability, log probability, I sum over the log probability of a word given the previous words, right, and the context. This is how you define normally the log likelihood of the data, right? So this is for the generation, and you can even weight the individual words, so they can be like IDF weights, inverse document frequency, or it can be uniform weighting, right? So how do you really apply this idea? So you're computing log probability of the generation, right, given some context. Now that was the interesting part about this paper. They said, this is versatile and you can use it for many different kind of things. For example, you want to measure faithfulness. Faithfulness means you have a source, you have a generation. How good is the, what is the probability of generating the hypothesis, your generation from the source, right? So this is how you can compute it. So that means you will compute the probability of the hypothesis given the source in the input here, right? So you can use this score, compute the faithfulness BART score. Similarly, precision is whatever you're generating, is it coming from the reference? So you will say from reference generating the hypothesis. That's your precision. So probability of hypothesis given the reference and the language model parameters. And the recall will be given the hypothesis, can I get back the reference? So what is the probability of the reference given the hypothesis? That will be the recall. So they had this 3 different nice ideas. They also computed the F1 measure by taking the precision recall together. So BART score is another evaluation measure. And as I mentioned, you're going to different domains. You may have to use some domain specific methods. And later we will also talk about how to use language models directly, LLMs directly as a judge for evaluating these summarization. And for this particular lecture, the various papers we have cited in the slides will be the reference. So this also ends our week 7. In the next week, we will start with instruction fine tuning and reinforcement learning, the new paradigms that will define the next 5 weeks for this course. Thank you.